The next section we want to look at is the ambiguous case given an acute angle. The previous section we did the ambiguous case when we were given an obtuse angle, and that one was really easy because if the largest side was not across from the largest angle, you could say no solution. But here in this case, we're either going to have 0, 1, or 2 possible solutions as we solve this out. Before I talk about anything with this, let's go back to geometry for a second. I'm going to give you a very simple example of a right triangle. If I give you this angle is 27 degrees, and I give you the hypotenuse is 12, what is the height of this triangle? And you'd solve this out saying, you know what, I'm given the opposite and the hypotenuse. So I'm going to use the sine. The sine of 27 degrees is the opposite, which is the height, over the hypotenuse, which is 12. 12 times the sine of 27 degrees equaled the height. And the height ended up being 5.448. So here this height is 5.448. And this situation that we can see here is an angle, a side, and a side. That's the situation that we're going to be dealing with the ambiguous case, something that's an angle side-side or a side-side angle situation. And we don't know if we're going to have 0, 1, or 2 solutions. So this is the visual that we're looking at. Now, hypothetical situation. What if I gave you an example and I said, you know what? Angle A is 27 degrees, side B is 12, and side A is 5.448. Is that going to be a triangle? And you'd say, well, of course, I just found it up here, it's going to be the right triangle. So yes, there is a solution. But let's say I gave you angle A is 27 degrees, side B is 12, and then side A was 2.153. What would happen to our triangle then? And if you're the deductive type of person, you would look at this and say, you know, given the fact that this is 27 degrees, which means that this line has to be down here and this angle is going off at 27 degrees, if my height is only 2.153, I'm not going to be able to complete this triangle. So what we're going to be working with is this height idea. We want to know what is going to be the minimum distance needed to complete this triangle. If I were to say angle A is 27, side B is 12, and side A was 7, would that work for a triangle? And you guys would say, yeah, it would work. It wouldn't be a straight line. If I had 7 units, I might have to come down over here more to fit a unit of 7 in, which gives me a little bit different looking triangle. Or maybe I come out this direction, 7 units, but I could still make a triangle work. So my goal for this whole section is going to be setting up some sort of triangle that's got an acute angle, and I want to know this H value. Is the H value that I'm given, or the side opposite that I'm given, long enough to complete a triangle? So that's going to be my whole goal in this section. And then once I know that, I can solve the triangles. So the major question is, how do my given measurements relate to the shortest distance between 2 points? And the relationship is going to be this H value, this height, where we use H equals B times the sine of A. But it could be D times the sine of Q. It all depends on what values we're given. But A is going to be the given angle, and then side B is the side not across from the angle. We want to find the side that is directly across. And is that height enough to complete the triangle? So the first situation that we're going to run into is zero triangles. It occurs when the opposite, or that height, is not long enough to complete the triangle. So the opposite, or the height, is not long enough to complete the triangle. So here I can see I'm given angle B is 50 degrees, side B is 3, and side A is 4. So the question that I'm looking at is side B long enough to complete the triangle? Because I'm specifically looking at the side that is across from the angle that I'm given. So is side B long enough to complete the triangle? So that's where we look at the height. So now we're going to find the height. And that's from H is going to be equal to the other side, A times the sine of B. I know that looks slightly different than the formula we have up here, but you can see I'm given an angle of B this time and not an angle of A, and my side is A that I'm working with, so they switch positions. So H is equal to 4 times the sine of 50 degrees, and if I solve that out, I will see H is 3.06. This 3.06 is the minimum height needed to complete the triangle given my side-side angle situation. So if I look at it, B here is equal to 3. I need 3.06. Since 3 is less than 3.06, no triangle can be created. So this one, we're going to have no solution. You have to do this check for the height, this H value. We cannot just say that we've got 0 triangles is produced when the opposite side is less than the adjacent. We can't say that. Because let's say this were to have been angle B is 50 degrees, side B is 3.65, and then side A is 4. Yes, side B is less than 4. That opposite is less than the adjacent. But since it's larger than the height, I can find that triangle. So my goal for these problems is going to be, can I have a height in order to solve this triangle? Is my opposite large enough in order to solve this triangle?